Picture this: a rock the size of a small airplane, flying through space at nearly 17,000 miles per hour, fast enough to circle Earth in just 13 minutes. On July 30, 2025, that rock, known as Asteroid 2025 OL1, will zoom past our planet at just 1.2 million kilometers away. That might sound far, but in cosmic terms, it's a hair's breadth. It's not going to hit us, but it's close enough to make scientists pay attention. This is the story of a fast, close visitor, and why these encounters matter more than most people realize. Asteroid 2025 OL1, measuring roughly 110 feet or 33 meters, is about as long as a small jetliner. NASA has been tracking it closely since its discovery in early 2025. On July 30, it will make a safe flyby at 1.29 million kilometers from Earth, roughly 3.3 times farther than the Moon. In this video, we'll explore what scientists know about this asteroid, the risks posed by near-Earth objects in general, and why each flyby is a valuable test for our planetary defense systems. Because, while this asteroid is harmless, the next one might not be. Asteroids are leftover building blocks of the solar system, and millions of them orbit the Sun. Most are harmless, but some cross paths with Earth. Even objects as small as 2025 OL1 can be dangerous if they hit. In 2013, a 20-meter meteor exploded over Chelyabinsk, Russia, with energy 30 times greater than the Hiroshima bomb, injuring more than 1,000 people and damaging thousands of buildings. The biggest challenge? Many asteroids are detected late. Asteroid 2019 OK, a rock over 100 meters wide, passed within 70,000 kilometers of Earth, closer than our geostationary satellites, and scientists discovered it just hours before its closest approach. This was a wake-up call that even mid-sized objects can slip through undetected if they approach from the Sun's direction or outside normal survey coverage. Predicting asteroid paths isn't easy. Small forces, like solar radiation pressure in the Yarkovsky effect, where heat causes a slow orbital drift, can nudge them over years or decades. Gravitational influences from planets or the Moon can further alter their orbits. That's why telescopes must track them repeatedly over days, weeks, and months to reduce uncertainty. Every new observation shrinks the error bars on their future paths and helps us avoid being surprised. And here's the scary part. For every large asteroid we've cataloged, there are countless smaller ones that remain invisible until they are very close. Earth's atmosphere protects us from most space debris, but an asteroid even half the size of 2025 OL1 could cause devastating regional destruction. That's why scientists say the greatest danger isn't from the known asteroids, but the ones we haven't yet discovered. To better prepare, space agencies worldwide have joined forces. NASA, ESA, JAXA, and other agencies share telescope data and early warnings. There are even plans for next-generation space telescopes designed purely for spotting asteroids approaching from the sun's direction, something that current ground-based telescopes often miss. These future missions' aim is to give humanity years, not just days, of advance notice. NASA's tracking confirms that 2025 OL1 is around 110 feet or 33 meters wide, big enough to cause serious damage if it ever hit, but far below the size of extinction-level asteroids. Its speed, relative to Earth, is about 16,900 miles per hour, or 7.6 kilometers per second, meaning it could travel from New York to Los Angeles in less than 5 minutes. Detection and tracking are handled by NASA's Center for Near-Earth Object Studies, CNEOS, which coordinates with international observatories. Telescopes like Pan-STARRS, the Catalina Sky Survey, and space-based infrared missions such as NEOWISE scan the skies for moving objects. Once an asteroid is detected, follow-up radar observations can reveal its shape, spin, and surface features. Radar is especially powerful. Using delayed Doppler imaging, scientists can build 3D models of an asteroid, critical for understanding how sunlight and heat affect its orbit over time. These techniques were famously used on asteroid Bennu, visited by NASA's OSIRIS-REx mission. That mission helped refine predictions of Bennu's future orbit down to how thermal emissions pushed it over decades. With 2025 OL1, follow-up observations rapidly reduced positional uncertainty, confirming that the asteroid will pass safely at about 1.2 million kilometers, well outside any hazard range. But the flyby is a golden opportunity to test our models, strengthen global tracking cooperation, and prepare for the day when an asteroid might actually be on a collision path. This event is also a test for upcoming planetary defense technologies. Missions like NASA's DART, which successfully altered the orbit of the asteroid moon Dimorphos in 2022, prove that humanity has the capability to protect itself, if we have enough warning time. Future missions, like ESA's Hera, will study the aftermath of the DART impact in even more detail, teaching us how to improve asteroid deflection techniques. Other proposed missions, such as NASA's NEO Surveyor, aim to scan the inner solar system with powerful infrared sensors, finding asteroids years before they come close to Earth. On July 30, the suspense reaches its peak as 2025 OL1 makes its closest approach, zipping past Earth at nearly 16,900 miles per hour. At that moment, it will be just 1.2 million kilometers away. Close enough in astronomical terms, but completely safe for us. For perspective, that's over 3 times farther than geostationary satellites and 3.3 times farther than the Moon. Yet in cosmic terms, it's a near miss. Encounters like this let scientists refine their calculations and ensure the asteroid won't pose a risk in centuries to come. If an asteroid of this size were to hit Earth, the result would be catastrophic for a region. The explosion could unleash energy equivalent to tens of megatons of TNT, creating a blast wave and a fireball capable of flattening an entire city. That's why planetary defense is such a priority for NASA and its partners. Missions like DART prove that with enough warning, we can detect a dangerous rock before it becomes a disaster. Events like 2025 OL1's Flyby are also vital for public awareness. Each encounter reminds humanity that Earth is not isolated from cosmic hazards. Our planet has been struck countless times in the past. Tunguska in 1908, Chelyabinsk in 2013, and far longer ago, the Chicxulub impact that wiped out the dinosaurs. One day, another impact will happen. The difference now is that, for the first time in history, we might have the tools to prevent it. In short, 2025 OL1, a 110-foot asteroid, will safely pass Earth on July 30, 2025 at 16,900 miles per hour, missing us by 1.2 million kilometers. It's not a threat, but it's a vivid reminder of why we scan the skies day and night. Each close approach sharpens our planetary defense systems, teaches us more about these wandering rocks, and keeps us one step ahead of potential future impacts. We may not always get decades of warning, but with every asteroid tracked, our odds of staying safe improve. What surprised you most about Asteroid 2025 OL1? Was it its speed, its proximity, or how much effort goes into making sure we're safe? Share your thoughts in the comments below. I'd love to hear them. And if you want to know more about how humanity is preparing for the day when an asteroid is on a collision path, check out our next video on NASA's DART mission, the first ever test of planetary defense. Thanks for watching. Stay curious, and don't forget to like and subscribe for more cosmic stories.